Hello, everybody. Welcome back to day 5 of the May number corner. What we have to do today is the calendar grid, and we have problem strings again, right? This is problem string number 29, so you're going to either need your problem or your number corner notebook or a number corner book or a piece of paper to record the problem string. We're going to start out by looking at the first calendar grid marker. So here, what we want you to do is to pause the video and add the nest number 2, where you go south four spaces or four lines from nest 1. So go ahead and make sure you record the coordinates on your coordinate graph and show us where that is. All right, so for our problem string today, we're doing multiplication of fractions, okay? We're going to start to notice a little pattern here once we get our little box in our array method. Okay, so let's start off with 2/3 times 3/5. So the first thing I'm going to do is I'm going to add a few more of those, and I'm going to divide my array into thirds, right? So as I'm dividing that into thirds, you can see that I have 3/3 or 1 whole. I also need to divide my other, I have to divide my array the other way using fifths. So I have to look at the denominator, and that gives me what I need to do. So I need to add 4 lines. That's probably not going to work there. There you go. So now what we need to do is we need to now look at our problem. If we have 2/3, which are these 2 lines here, and we have 3/5, which are 3 lines here, we have to think, which squares get overlapped. And if I'm looking at this, it would be this square, this square, this square, this square, this square, and this square, which would give me 6. So I had a total of 6 squares that got overlapped out of how many? And I can figure that out by 1, 2, 3, 4, 5. 5 times 3 is 15. All right. Okay, let's move on to the next problem string. Go ahead and stop the video and go ahead and finish the next problem. Okay, so hopefully, or you could finish the rest of the problems too if you needed to. Okay, so we're going to maintain the thirds. So I'm going to keep thirds here, but then I'm now dividing it by 3/4. So I have to add 3 lines. There you go. And I'm going to use those 2/3, and now I have 3/4. So what do you notice here? How many spaces does it overlap? Did you say 6? Yes, it does overlap 6 spaces. But we don't have 15 like we had in the problem above. How many spaces did you see that we had total here? 12, correct. So actually 1/2, right? Because we have 6 here and we have 6 here. Cool. All right, next problem. We're going to multiply 3/4 times 2/5. I'm going to keep my fourths, but now I'm going to add my fifths. So I have to break my array up and down by 5. There you go. So again, we're going to go 3/4. So 1, 2, 3, and 2/5. 1, 2. And what do you notice? How many squares or rectangles, I guess, do we overlap? We overlap in 1, 2, 3, 4, 5, 6. 6 again. But for our denominator, we have so many more spaces on this graph, correct? Or on our array. how many squares are there in total? Well, 1, 2, 3, 4, 5 times 4 is 20. Good. All right, so now let's think, how am I going to go 3/5 times 10/3, right? Bridges always throws in that extra one. What did you notice while multiplying here when coming up with our answers? I noticed that when I multiplied 2 times 3, I got 6. And when I multiplied 3 times 5, I got 15. 3 times 2 is 6. 4 times 3 is 12. 3 times 2 is 6. 4 times 5 is 20. So what should we do here? Right? I should multiply 3 times 10 and get 30. Is that what you got for your answer? And we're going to multiply 5 times 3. What do you get for that? 15, or 2 wholes. All right. If you have any questions with this, or you don't know where to put Mumford Moles' second nest, please reach out to your teacher. If not, have a great day and enjoy math.